I'm an obsolescence guy, and if you inquired with my two daughters, they would tell you that I'm an obsolete guy, but that's a different discussion, right? So, but I'm not going to talk directly about obsolescence management, but rather a potentially big problem, okay, that's coming our way, okay, or maybe it's already encountered you, that will impact potentially how we do manage obsolescence. Okay, so I want to talk specifically about outcome-based contracts. All right, so first off, let's define sustainment. Everybody in here has a definition of sustainment in their brain. Here's a nice, very general definition of sustainment. Of course, in this definition, the footprint can vary depending on who you are and what kind of product you make, and the stakeholders will vary as well. But this encompasses about everything in the sustainment world. Now, we hope that sustainment doesn't happen like this, okay? However, most 90% of the sustainment in the world is like this, okay? And this is what we call this transactional sustainment, or, well, my kids call it whack-a-mole, right? So this is what, unfortunately, a lot of us end up being involved in, okay? All right, so when we talk about sustainment, it's a piece of a bigger view, okay? And the buzzword today in industry or in academia as well is resilience, right? Resilient systems, right? So no question that resilient systems means designing resilient hardware and software. Okay, everybody would agree on that, although that's probably where sort of the agreement stops, okay? But resilient systems really are a bunch of other things. Okay, so they're hardware and software, no question about it. They're also resilient logistics, right? So that's where we come in, right? Obsolescence management is part of that. This is managing aging supply chain problems, counterfeit parts, obsolescence, etc. It's also workforce management, right? Your workforce can become obsolete too. It's a resilient contract structure, which is what I'm going to focus on here in a couple of minutes. It is resilient governance, okay, which is the legislation and policy that you're under, okay? It's also a resilient business structure, okay? So all these things got to come together, and if they don't, if you blow just one of these, the whole system isn't resilient, okay? So got to figure out all these things, all right? And I think one of life's guarantees is up there at the top, right? Any system you're working on today, our new systems today are going to be tomorrow's legacy systems. And you're going to support them, and your kids are going to support them, and unfortunately, probably your grandkids are going to support them forever. Okay, so that's the way things are. All right, so let's talk a little bit about contracts. All right, so there are a bunch of different kinds of contract mechanisms for sustaining systems, right? So I have three big categories there on the left, but there's some other smaller things out there, but let's look at these. So break-fix guarantees, these are commonly your maintenance contracts, right? But warranties and leases kind of fall in this space too. Basically it says if it breaks, it'll be replaced or fixed. Okay? You have satisfaction guarantees. These are more for commodity items, things like food and stuff like that. They have no actual quantifiable satisfaction, okay, but presumed satisfaction from the user will replace or refund. And then we have outcome guarantees. That's where we're really interested, okay? So the mechanism here is really an outcome-based contract, okay, which is a contract where where the customer's desire to buy an outcome instead of the service or the system, or instead of the system, okay? Sometimes these are also called product service systems, okay, fit in this category, all right? So in these contracts, they differ from the others because satisfaction here is very strictly quantified, okay? And it's usually quantified using things like availability, stuff like that. Okay, maybe some other performance metrics as well, but availability is a good one, all right? So the big deal here is under an outcome-based contract, at least in theory, the provider has the autonomy or some autonomy, okay, to meet whatever the outcome requirement is any way they want to. Okay, that's the advantage for the contractor. All right, so there are a bunch of common outcome-based contracts already out there, okay? Here's one, okay, so in the defense world, okay, there are starting to be, in the United States, we would call them system-level PBLs, performance-based logistics. There's other performance-based logistics that's not system-level that we'll leave out of this discussion. It's a little different, okay? But in these cases, at least in theory, okay, the customer purchased the availability of the system, okay? And then it's the responsibility of the contractor, okay, to keep that system running as long as the contract goes, okay? That may be a little bit wishful thinking. We're not quite there, and different laws in different parts of the world will govern how long these contracts can be and things like that, and we're not really to a lifetime sort of contract yet, but we're getting there. Okay? Power purchase agreements have been around for a long time. Okay? They're most commonly used for renewable power, wind farms, solar farms, but they also exist even for coal-fired power plants. In these cases, the utility does not own the generation. Okay? The utility doesn't own the wind farm. It simply contracts for energy from the wind farm. Okay? So whoever owns the wind farm is under a PPA, power purchase agreement, that says you will provide X amount of energy per year. Okay? And if you can't provide that, if the wind doesn't blow or the wind turbines are broken down, okay, the customer actually doesn't care. The customer says you have a contract to deliver, and what a wind farm might end up doing is buying energy from another source to deliver, to make the PPA. Okay? In some parts of the world, varies by part of the world, for instance, the United States, there also are minimum requirements on PPAs, okay, that say that the customer has to purchase a minimum amount of power or energy per year. Okay? So that depends on various issues with energy security and prices of gas and oil and things like that. So, all right, so PPAs have been around for a long time. These are outcome-based contracts. Another common outcome-based contract are public-private partnerships. Okay? In the United States, they're most commonly used for building highways and bridges, tunnels, toll lanes on highways, things like that. One way they might work in the USA is that a private corporation builds the toll lanes for a highway, and then they're allowed to collect the toll for a certain number of years if they meet certain minimum availability requirements of those lanes. Okay? If they exceed those requirements, they might be able to collect the toll for more years. Okay, so these are all outcome-based contracts. Okay, they're around with us today. Okay, so why am I talking about this? What's the deal? What's the challenge? Okay, so ideally the contract should be designed concurrently with the system. It doesn't happen today. Okay, there's a wall. All right, so the system gets designed, the contract gets designed, one or the other goes over the wall, and that's simply what you use. Okay. In this case, also the optimums. Okay, if there is an optimum, a best contract, a best design, is for a population of systems, not an individual system. Okay? From the examples, availability, okay, of energy from a wind farm is a function of 100 turbines in the farm, not one. You don't have a PPA for one turbine. You have it for a set of 100. And if one is down, maybe that's not a problem. If 10 are down, you got a problem. Okay, so a population of system is what counts, not the individual. Okay. And third, designing a system to operate optimally under an outcome-based contract is what we really want to do. Okay, so we haven't really thought a whole lot about, here's the contract that you're going to have to manage for the next 20 years. Now, how do you change the design of the system to allow you to do that optimally? Okay, so what does failure look like here? Okay, this is a reasonable question to ask. So if I blow these, what happens? Okay, what's the bad stuff? Okay, so contract failure means usually that a significant amount of money has been spent for no outcome. Okay, so here's an example of a failure. Okay, maybe you can't quite read that. It's SR 125 highway in California. So it's a highway that was built under a public-private partnership. Okay, the contract ended up driving the contractor out of business. Okay, and then what they're stuck with is a half-finished highway that a huge amount of public funds have been spent on, and nobody can drive on. Okay, so it's a lose-lose, right? Disasters for outcome-based contracts, everybody loses. The contractor and the customer lose. Okay, so it's worth it for everybody to design these right. You design an optimal system and contract, and everybody, customer and contractor, win. All right, so here's an illustration for you. Okay, so this is a Torpedo Enterprise. Okay, it's an inventory of torpedoes for a submarine fleet. Okay, these are provided under an availability contract. Okay, so the provider of the torpedoes gets paid in part based on the availability of the torpedoes realized by the customer. Okay. And so in this case, there are exercises of deployment that require constant servicing of these torpedoes. During that testing, okay, if torpedoes are found to be somehow defective, they're replaced by the contractor, okay, and returned to the fleet. Okay, and so there's this diagram at the bottom which sort of shows that process, right? So here, what's the problem? Okay, this is an availability contract. So here the real question is, when I measure availability, so availability is the fraction or percent or probability that a system will be available when you need it. Okay, so it's usually the uptime divided by all time. That's simple operational availability. There's other flavors of it, but that will do. Okay, so the question is, what's the time interval over which you measure it? Okay, so do I measure availability monthly, quarterly, annually? Okay, I'm going to hold the contractor to it, so how often should I measure it? Okay, so today's solution to this problem is that we'll see whatever they did in the last contract, we'll cut and paste into this contract. That's how it's done, right? That's not an overstatement. That's really how it works. Okay, so what's the best interval? Okay, so I know that if I assess too often, an assessment costs money. If I assess too often, it's going to be pretty expensive. Okay, I know if I assess too little, okay, there's a significant risk that the customer's availability requirements are not going to be met. So what's the optimum? So in this case, okay, I'll go through this slide quickly, but this is the solution that was done in this case. It uses an affine controller solution. It looks like this thing down in the corner. Lots of words, but basically it's a controller that looks at torpedo demand in the past, torpedo expected demand in the future, plus the inventory levels and the holding costs for those inventories and all that stuff. Material availability, basically. Okay. All right, so what do you get? Okay, this is the more important part, is here's a plot of annual cost to the customer, lower is better, okay, versus the availability assessment interval, the window in the contract that says how often the contractor will get paid or will be assessed on the availability from which they get paid, okay? So the first important result here is there's an optimum, right? All those curves, they all represent slightly different costs of doing the assessment, but they all have a minimum in them. Okay, so that in itself is an interesting result. So they all have a minimum. And in fact, this lowest curve here, which is the lowest assessment cost situation here, turns out to save between 5 and 8% of the total operational cost. Okay, that's not pennies. Okay, that's bigger than the coffee fund. Okay, that's enough that people are interested. All right. So, and it's only 25 days. Okay, so if this thing was a quarterly assessment, that's a lot of money to leave on the table. Okay? The other thing you can see is that obviously as the cost of assessment gets bigger, okay, the length of the window gets longer. Okay, that's sort of intuitive here. All right, so interesting result as well, this little in black over here. So, is that this assessment is done with a complete lack of information about the contractor's cost schedule or cost structure. Okay? That's important. We'll see that show up on the next slide. Okay? All right, so what's emerging out there is this thing called contract engineering. All right, so contract engineering, it's not a payment structure. It's a combination of all these things. So it's people looking at contract theory. Okay, so and the important thing there is you see buried in the contract theory words in green up there, it says information asymmetry. Okay, that's the deal on the last slide where both sides don't know everything about the other side. You don't know about the contractor's cost structure, or the customer doesn't know about it. And the contractor may not know about all of the customer's motives. Okay, so there's information asymmetry is a big part of it. So contract theory, by the way, the 2016 Nobel Prize in Economics was in the contract theory space. Okay, so it's also contract mechanism design. Okay, choosing the actual type of contract that you use, and then it's co-design, right? How do you design the contract and the system all at the same time? Okay, so it's not over the wall. So in the intersection of all those things is what is called contract engineering. Okay, so what about sustainment now? Well, we defined sustainment up front. Okay, let's get back to it here. So, you know, the days of selling a system and then collecting for the maintenance, okay, which is how a lot of the contract world has operated and still operates now, okay? Those days are in some cases dwindling, okay? Outcome-based contracts attempt to put that kind of business model out of business, okay? So if a customer only buys an outcome, then the contractor is going to be responsible forever, however long forever is, okay? And this all leads to the fact that now the contractor really has a motivation to be strategic and not tactical, right? If you're in the first model up there, you can be tactical, right? If the customer's going to pay, you charge the customer if you want to refresh the design of the system or manage it in some heroic way, right? So, but in this case, the customer is going to say, I don't care, right? You own it. You figure out how to best manage. So you want to be strategic, right? So here's my, kidding around, but you've all been there, right? The moment you close the cupboard and hear something fall, that's the sound of somebody else's problem. Well, guess what? Not anymore, right? That's the sound of your problem, okay? All right, so let's talk strategic for a minute. Okay, so here's a strategic refresh planning solution. So in the obsolescence management space, the strategic solutions are what we call DRP, design refresh planning. Doesn't take the place of everything else, okay? You still do reactive, you still do proactive, but if you're actually planning the life cycle, you're doing design refresh planning. That's strategically figuring out where you design refresh and optimally figuring out what you do in between. Okay, so here's a design refresh planning solution. Okay, so this is a Motorola system. It's a system that they sell to cities, okay, for fire and police radio and things like that. They were managing this system via all lifetime buys. Okay, so that's the dark blue line at the top. It was expensive. Okay, one day the CFO of Motorola said, why do we have hundreds of millions of dollars worth of lifetime buy parts? Okay, at which point the engineers said, well, we know if we put a refresh in the system like anywhere, we would be better off, but we've never been able to sell that to management. Okay, therein lies the problem. Okay, fundamental problem, engineers are not really very good at making business cases. They're good at finding problems, they're good at solving problems and complaining that the sky is falling, but they're not very good at making a business case to management or the customer. Okay. All right, so what you see on this plot is life is cost on the vertical axis, lower is better, versus dates down here. All these little colored spots. Okay, data points are all unique combinations of design refreshes for this system. Okay, turns out that the best one, this is from a while ago, is the single refresh in 2011. It's about right there. Okay, that was the best solution. And in fact, the cost avoidance here is about 33 million bucks. Okay, that's for one band of the radio, not the whole thing. Okay, so all lifetime buys versus a single refresh, which is bridge buys up to that refresh and lifetime buys after. It saves that much. Okay. All right, this is fine. Okay, but this really isn't a business case. Okay. What closes the deal is when you do this. You say, hey, there's uncertainties here in everything. Okay? Hey, I'm responsible for some of those obsolescence forecasting algorithms. And I know that they give you plus or minus 4 years. Okay? So there's uncertainties in everything. Okay? And that's not the only thing there are uncertainties in. Alright? So if I look at the all lifetime buy solution and the 2011 refresh here, take the difference between them and then incorporate all the uncertainties. Uncertainties in how much it's going to cost, uncertainties in when things go obsolete, even uncertainties in the end of support date. That's a big one. Okay? And you plot that difference, you get this. Okay, so the answer here really isn't 33 million, it's about 31 million, but it could be as low as 27 million, as high as 36 million. It's somewhere in that space. And in fact, once you got this, you can start to do some confidence stuff. Okay, we could go back to Motorola and say, have an 84% confidence that it's 30 million or more. Okay, so that closes the deal. Motorola went and did the refresh. Okay, so strategic solutions with business cases. All right, so final comment here, right? So if we design or select a component for a system, are we going to select that component to minimize its life cycle cost? Well, not a bad thing to do. But the answer is no. Okay? Hopefully not. How about to minimize the life cycle cost of the system that it's in? Better. Okay, but no. Alright, don't like that one either. Okay? It's really to minimize the life cycle cost of the enterprise that the system is in. Okay, so if it's an airplane for an airline, we got to look at the whole airline. Okay? That's how you ought to be picking apart. Which is a little different. So that's where the Gold Coast is. All right, so outcome-based contracts don't shift the responsibility for sustainment. A lot of people think they do, right? Sustainment's going to be somebody else's problem. That's what the customer thinks. Okay? And that includes obsolescence management. Rather, they simply shift the liability for incompetent obsolescence management. Okay, so be careful. Even the customer's not out of the loop here. Right? So you go just as bad. All right, so everybody here is involved in this, ultimately. Okay, so the question is whether are you going to be part of the problem, part of the solution here? Okay, so outcome-based contracts are coming. So with that, I think that's it.